Hello everyone, welcome to my YouTube channel Go Smart. In this video, we are going to discuss about a streaming application where I'm reading data from a Kafka system and writing it into a delta table. As you can see it in the screen, we have three components here. We have a mongoDB, we have a Kafka, and we have Spark, Apache Spark. So MongoDB is acting as a producer which is producing messages to the Kafka system. Kafka is consumed from the MongoDB via Kafka connector. In in the other side, we have Apache Spark, that's the final table, which is reading data from the Kafka system and finally writing it into a delta table. So I have set up this MongoDB in my Windows system. My Kafka is in the Ubuntu, WSL, and Apache Spark in my Windows system. So let me show you how my MongoDB looks like. So that's a MongoDB, and we have a database called Amazon database, where I have some tables like orders, product groups, products, and users. So these three tables called orders, product groups, and products are more of a dimension table, where we are no product groups, products, and users are more of a dimension tables. Product groups is used to store the details about the product categories, and products collection is used to store the product details. Users table collection is used to store the user details. Let me show you how this products collection looks like. So this products collection is associated with the product groups collection, where we are referencing its product group ID. Product has its product ID. Then we have a product name. So this is about products collection. These tables normally don't change, and we are not streaming the data from these tables. We are streaming the data from the orders table. So this is our main table here. So in the orders table, we have the order ID, we have the product ID, and the user who had set up this order. So these are basic informations we are setting up initially. So this is about the MongoDB. Now coming to the Confluent Kafka. So I've said Confluent Kafka, I have set it in my Ubuntu WSL. So I've started my Confluent Kafka using the above command. Now my Confluent Kafka is up and running. I'm connecting to the MongoDB using the configuration using the connector file. This is the connector file mongodb source.json, where I am defining some configurations like the URL. This is my Windows IP machine IP, and the database from where the collection is present. This is the collection name, and the startup mode is the copy existing. So whatever the data that is present in this collection orders, it is all going to be written into our Kafka topic. So this is about my Confluent Kafka. Now I have already started a consumer which is going to consume the data from the MongoDB, and I have a consumer group called orders Kafka group. Uh, as you can see in the screen, it has some details like what is the current offset, what is the log end offset, what is the lag value, who is the consumer ID, what is the consumer ID, and the host details. I can also query the MongoDB from the Ubuntu machine. I have installed MongoDB client here, and I've already connected to the Windows to the MongoDB using the above command mongosh and passing the IP here. So these are the few details. So now my Confluent is set up. My MongoDB is also set up. The Confluent is ready to consume the data from the MongoDB. MongoDB is also up and running. Now I'm going to build my Spark streaming application. Spark streaming code. Here I am specifying the Bootstrap server detail, the IP. This is the Bootstrap server IP, from where the Kafka is installed. That's the default port. Our topic name. So once you define the connector here, it is going to create a topic. Once you're going to deploy the connector here, it is going to create a topic in the name called database.collection. So that's what it is mentioned here. And this is a Spark object. I have defined it here. It is very similar. Using the Spark session, I'm building the Spark object here. Now I'm going to read the data from the Kafka broker. This is the Kafka broker detail. Then this is the topic name. I'm going to include the headers. Starting offset is the latest detail, latest offset. So whatever the new data that that are going to be pushed from MongoDB and present in the Kafka, I'm going to consume them. I'm going to commit. Once I consume the data from the Kafka, I'm going to commit them. What is the consumer group ID? That's mentioned here. And fail on data loss. So if a particular data, if the data are not present in the Kafka, in that instance our streaming application might fail. So I have set it to false. Once I read the data, I'm going to cast these records, whatever it is written we are reading. These are the data that we are reading, like order ID, group ID, username, okay, and a few other details that are sent by the Kafka. If all of this I'm going to cast as a string format. Now I'm checking whether the streaming is running or not. Then I'm going to write it into a delta table. This is our delta table, retail.orders underscore Kafka, where I'm going to write it. So I'm writing it using write stream and storing it in the delta format. Output mode is append. All the new records that we read it from the Kafka will be appended into the delta table. Processing time, I have set it to 1 second. So every 1 second, my application is going to uh, pull the data from the Kafka and write it into my delta table. I've set the checkpoint location, and fail on data loss again also I have set it to false in this case also. So mentioned here the table details. Now I'm going to start writing. So first I'm going to create some data in the MongoDB and check whether it is getting consumed by the Kafka or not. Uh, so you will see one data I've already created. Now it has been already been consumed. Just look at this numbers. Current offset is 13, log is also 13. Now once I create some records, this current offset and log offset will also change their value. Since our consumer is up and running, our log end offset is also going to increase accordingly. So let me create some orders. Let's say it's 13, order number 13, product ID, let's say be it 8, and the username is Sangram. So I'm inserting a data into the mongoDB collection orders. Now this particular data has been inserted into the mongoDB collection. As you can see now, this new data has now been consumed by the consumer. Let's check in the consumer group these details. As you can see, the current offset now has been set to 14 and log end offset has been set to 14. So this is now our data is now ready in the Kafka. Okay, you can also check it from the control center. Okay, we have some data here. Offset is 13. Now going to check this data. If I open the notepad, and so we created a record like the order ID was 13, and probably this is 13 only. Yeah, you can see it's order 13, product ID is 8, and username is Sangram. So this has already been consumed by our Kafka topic. Okay, now I'm going to, I haven't started it yet, my streaming Python query, but let's check the data that is already present in the delta table, retail.orders Kafka. So I'm going to query this table. Let me check the first the count. Now, initially before running the streaming app query, let me check the count of this particular table. Okay, we have 13 records. You can see. Now, once I run my Python script, once I start writing it into the delta table, our uh, record count in this table called retail.orders Kafka, it's going to increase. Initially it will be 14, then 15, 16, and so on. So that's what we are going to verify it here. Now I'm going to, all right, we had 13 records in our table. Now I'm going to run our Python script to consume the new records that I had created in the mongoDB. So let me start. I've set my application to run for 60 seconds. So once it is completed, streaming will stop, and whatever the records that it pulled from the Kafka within the 60 seconds will be written into the delta table. So it's yet to start. All right, yeah, it's started. Is streaming, it is running. Now it is going to write. Okay. Okay, let me see how many records. Um, so few minutes back, I did check the status of the number of the records that are present in the orders Kafka group. Now, what you can see here is three more records are consumed by the consumer. So now it changed from 13 to 16. Okay. So let me make you understand. Initially, when I consumed two records, and after then when I consumed another record, I didn't started my consumer. So once I started the consumer, all got in sync. So as of now, we have 16 records. So once it is completed, we will verify the record count in the table retail.orders underscore Kafka. It's taking a while. Okay, we have some records like 15, 14, and 16. You can see the now record with offset 15 was recorded on 5:58 p.m. Recorded with 14 was inserted at 5:12, and the other one at 5:13. I think until 12. Okay, that was at 3:58. Now the rest the records were yesterday. All right, must have completed. Yeah, now we can see. All right, now we can get the count of the number of records present in the table retail.orders underscore Kafka. Will take a while, let's say 10 seconds. Right, now you can see after 13 and three more records that I created are now inserted. Now I can see the total number of records has increased from 13 to 16. So that was the number of records that was consumed by our consumer group 16. So here then we can conclude here that our streaming application is working as expected. The number of records that were that are present in the mongoDB are in sync with our delta table present in the Apache Spark. Okay, so this concludes our session today. And if you have any questions, do let me know in the comment section. I'll be happy to assist you. Thanks for watching this video. Thank you.